sudden impact, and scorching flames.
I thought, am I gonna die?
A fiery crash nearly kills a racing legend.
Thank God I made it through.
But for driver-turned-airline owner Niki Lauda, a more devastating accident is still to come.
I had a phone call from the news. They said one of the airplanes crashed.
We just couldn't find the smoking gun.
Austria's famous champion defies conventional wisdom.
If they had lost only 10%, they would still be here.
Fights to uncover the truth.
It's my name, my airplane, my crash.
And discovers a new and widespread threat to modern aviation.
You need a little bit of rudder trim to the left, huh?
What's that?
You need a little bit of rudder trim to the left.
Okay.
Captain Thomas Welch and First Officer Josef Thurner are flying a Boeing 767 from Bangkok, Thailand to Vienna, Austria. The flight is operated by Lauda Air, the brainchild of famed Austrian Formula One driver Niki Lauda.
For me, it was a logical step after retiring from racing to start in this kind of business. And that's what I did with Lauda Air.
Throughout the 70s, Lauda dominated Formula One racing.
Niki was the best driver in his days.
Niki Lauda's Ferrari still in the lead.
I think Niki is the best known Austrian since Mozart.
And that's how they finish. Niki Lauda takes the flag.
He won the World Championship 3 times, then used his fame to launch a new career and a new airline.
One of the main reasons was to give the passengers a different way of flying, better service, better food. The airplane had to look in a certain way.
The Lauda Air 767 is less than 15 minutes into its 11-hour flight to Vienna. It's a route Niki Lauda knows firsthand, because he's not just the owner of the airline. He's also one of its pilots.
When you run a company and you fly, it's very simple. Because when you are with your passengers, then you know what is going on. You can look yourself what the problems are, and I corrected things quicker in that way.
Culture 13, plus 13, plus 2 is 20.
In the cockpit, Captain Welch and First Officer Thurner monitor their instruments, while the autopilot controls the climb. Suddenly, the plane begins dropping from the sky. The pilots have lost control. Lauda Flight 4 is plummeting to Earth. The plane slams into a remote jungle, 110 miles northwest of Bangkok.
I was at home and I had a phone call from the news station here in Vienna, and they said one of the airplanes crashed.
When rescuers arrive, it's immediately obvious that there's no one to be rescued. All 213 passengers and 10 crew members are dead.
The airplane took off at 16:01 UTC. There was no fault or whatever reported from the pilots. The airplane flew about 20 to 25 minutes and then suddenly disappeared off the radar screen. So we have no indication whatsoever happened to the airplane.
It's the first time a Boeing 767 has ever crashed. The loss of a US-made aircraft prompts quick action from the National Transportation Safety Board. The NTSB immediately sends veteran investigator Bob McIntosh to Thailand.
A first crash of an aircraft that was in service intercontinentally for almost a decade with a perfect service record. It was extremely important for us to learn what had happened.
223 people are dead, and one of the world's most popular planes lies in pieces in a remote Thai jungle.
Most of the territory was mountainous, very tropical type territory. We recognized that we were going to have a major challenge trying to identify all the components.
The difficult terrain isn't the only problem the investigators are facing.
There were numerous local folks around, and unfortunately, they were not controlled by the local police. There was looting and treasure hunting going on around the crash site.
First thing we got to do is put a stop to that.
Looters are swarming the wreckage. Vital evidence is in danger of disappearing.
It was of great concern to us that critical parts might have been taken away from the site simply by folks who didn't understand the criticality of that evidence.
The badly burned wreckage is strewn over a square mile of rough terrain.
We were confronted with what appeared to be evidence of a in-flight breakup, in that the major components, the cockpit, the tail, the main body, they were scattered far enough apart that certainly they had not come down together.
The large field of debris leaves McIntosh with little doubt. The 767 broke up in mid-air, not when it hit the ground. What could have caused that?
So it sounded like an explosion.
Witnesses say the plane blew up and came down engulfed in flames. The evidence is pointing to a troubling possibility. Lauda Air Flight 4 was brought down by a deliberate act of sabotage.
There was a lot of speculation about the possibility of a terrorist act affecting the aircraft.
Glad to have you on board. Let me show you where we're at so far. This is Fred.
Boeing sends its own investigator to Thailand. Kevin Darcy has an intimate knowledge of the 767. He helped design the plane. He too suspects this could be a case of foul play.
And it's pretty unusual for an accident to occur on the early climb-out portion of the flight. My initial thought was that it was some sort of sabotage or a missile or something like that.
It's been just 3 months since Western powers pushed Saddam Hussein out of Kuwait in the Persian Gulf War. The timing sparks rumors of a revenge plot, a terrorist attack against a soft target, Lauda Air.
They pop into your mind, ideas like that, and you have to work kind of hard to get those out of your mind so you can just see where the facts take you.
The passenger list suggests a possible lead. One of the people traveling on Flight 4 was an advisor to the United Nations Drug Control Program. Donald McIntosh was helping the Thais fight a war on heroin. Perhaps the powerful drug barons who rule Thailand's Golden Triangle have somehow engineered the disaster. Investigators begin the painstaking task of testing the wreckage for explosive residue. Airline owner Niki Lauda is reluctant to believe terrorism brought down one of his planes. He arrives in Thailand to see for himself.
My first decision was to go there myself and try to find out what happened. And this is what I did.
Where was the tail found?
I've never seen an airplane crash in all my life. The scene for me, this was the most horrific pictures I've ever seen.
Surrounded by the scattered remains of an airliner that carried his name, Lauda is overwhelmed by the magnitude of the disaster.
When you have 223 people killed, the families all want to know why. And I think this is the worst for people if they do not know why they lost their husband, children, or whatsoever.
Lauda is determined to figure out what went wrong.
If it's the fault of Lauda Air, technicians or pilots, I'm responsible for everybody, I will certainly resign.
His conviction may be rooted in his own traumatic past. At the German Grand Prix in 1976, his Ferrari slammed into a wall and erupted in flames. Lauda suffered third-degree burns to his head and body. He barely survived.
And I said, I'm not going to die. And thank God I made it through. But it was very touch and go, not because of my burns, it was my lung damage, which was the problem.
His lungs were badly scarred from inhaling toxic burning fumes. But in spite of his injuries, Lauda only missed 2 races.
Just 40 days after doctors had given up hope and a priest had knelt at his bedside, the Austrian ace climbed back into the cockpit of his glaring red Ferrari.
He was back on the track 6 weeks later. But the cause of his near-fatal crash was never uncovered. This time, he wants things to be different.
After the crash near Bangkok, the only way for him to survive as an intact person was to find out what really had happened.
Finding answers won't be easy. Early evidence from the crash site is already raising doubts about the bomb theory.
One of the most important signatures in looking at terrorism is to look at the baggage containers in an aircraft and see if they're damaged in any way and what that damage is, if there are signatures of explosions.
I don't know. There's no charring. There's no outward pedaling. Doesn't say bomb to me.
We didn't see any evidence of terrorism.
The black boxes may have captured important clues about the cause of the in-flight breakup, but they're badly burned. To have any hope of retrieving the data, Thai investigators need to send the boxes to a sophisticated lab. Bob McIntosh makes the case for the NTSB to get the job.
They should go to Washington.
There was an obvious reason, and it was because the aircraft is certified by the United States FAA, and the manufacturer is located in the United States.
Days after the crash, crucial pieces of the plane are still missing, including the engines.
Tracking down the wreckage at the Lauda crash site was certainly a major challenge. It was mountainous. It was totally overgrown. We climbed a mountain, went back down in a valley, and found the left engine.
Well, would you look at that?
Then investigators see something that sends a chill through the aviation world. Investigators in Thailand have made a surprising find. The thrust reverser on Flight 4's left engine is fully deployed.
Once we actually saw that the thrust reverser had deployed, for me it was shocking. It was not anything I really expected would happen.
Thrust reversers help jetliners come to a stop on landing. They work by redirecting engine thrust forward to slow the plane down.
Left side deployed in midair. No doubt.
Planes have built-in safeguards to prevent reversers from deploying during flight. But even if it does happen, it shouldn't cause a crash.
The widespread feeling of what would happen if a reverser deployed in flight was that the airplane would be controllable, that you could make a safe landing after that happened.
In fact, flight testing has already shown exactly that. Before the 767 first went into service, Boeing had to prove that pilots could keep flying safely after a mid-air deployment.
I was actually on one of the flight tests when we tested the thrust reverser deployed. There was a lot of vibration, a lot of noise, but the airplane was controllable.
The pilots only experienced a small loss of lift. As a result, Boeing certified the 767 as capable of continued safe flight and landing under any possible position of the thrust reverser. But the discovery of an engine with a deployed reverser is so unusual, investigators must conclude that it's somehow related to the crash.
How does a thrust reverser bring down a 767? We're missing something.
If it turns out that a faulty thrust reverser can bring down a plane, it has ominous implications for the entire airline industry. The lives of hundreds of thousands of passengers around the world could be in jeopardy.
We recognized that we had something that was very unusual and would require a lot of analysis.
The deployed thrust reverser is the strongest lead investigators have. But no one can figure out how it could have caused the crash.
What would have caused the loss of control of the aircraft? Because it had been demonstrated that this very condition could occur in the air, and you could continue to land.
Investigators will have to solve the mystery without their most valuable tool. The flight data recorder is so badly burned that technicians at the NTSB can't recover any data.
The disappointment was the flight data recorder was completely destroyed, which was very unlucky.
But there's better news about the cockpit voice recorder. It has survived the fire.
Ready to go?
Investigators on both sides of the world can finally listen to the last moments of Lauda Air Flight 4.
Radios. Check.
For me, it was very important to listen to the voice recorder, to understand things in a better way, because you need answers.
V1. Rotate.
We recognized that the first officer had been in the pilot monitoring position. The captain was flying the aircraft.
Positive rate of climb. Gear up.
The voice recorder shows a normal takeoff and climb.
Landing gears up.
All this kind of normal communication, which I knew all the people. So for me, it was honestly hard. This is the hardest part of all my life.
We are clear to level 310 and maintaining Lauda 4.
Flight 4 climbs to 7,000 feet without a problem. A little more than 5.5 minutes into the flight, the first hint of trouble.
Scheiße. That keeps,
What's come on?
What's come on?
Some kind of warning.
The pilots have noticed an alert that's come on in the cockpit. Could this be the clue that unlocks the mystery of Lauda Flight 4? Investigators listen as the Lauda pilots discuss a mysterious cockpit warning.
What's it saying there about that? Additional system failures may cause in-flight deployment. Expect normal reverse operation after landing.
Stop it for a second. Additional system failures may cause in-flight deployment. He's talking about the reverser isolation valve warning.
The warning relates to a valve in the left engine's thrust reverser. The hydraulic isolation valve controls the flow of hydraulic fluid to the reversers. When it's open, the reverser can be stowed or deployed. When it's closed, the reversers won't budge.
Okay.
The crew doesn't sound worried about the warning.
The reverse isolation warning that was presented to the crew was an abnormal but not emergency issue, and it didn't require any action by the crew other than to be advised that the thrust reverse might not be available on landing.
Okay.
They did the right thing. They read the checklist, and the checklist said you can continue the flight.
Should I ask the ground staff?
It's probably moisture or something. Because it's not just on, it's coming on and off.
Yeah.
It was a non-emergency issue, and they simply discussed it.
You know, it doesn't really, well, it's just an advisory thing.
To make sure that they felt comfortable that it was not something that was going to interfere with the flight.
I don't, it could be some moisture in there or something.
Kraftstoff 14. 5 plus 18. S14. 20.
For 5 minutes, nothing happens. Then...
Reversers deployed! Oh, Christ!
The captain said, damn it, and reactions of a pilot which is out of control, basically. The co-pilot didn't say a word in these moments of the crash. So for me, it was very obvious that something must have happened there so quickly, because normal pilots, they communicate with each other if there is a problem.
The CVR confirms that whatever went wrong, it happened blazingly fast. Just 22 seconds later, the sound of the plane being ripped to pieces.
The whole thing was so difficult. you never forget.
Niki knew that it had to be a mistake, which was not the airline's mistake, not Niki's mistake, and not the pilot's mistake.
Niki Lauda is convinced the deployed thrust reverser is what caused the crash.
The moment Niki was sure that there was something wrong with the system, he put a lot of pressure on Boeing.
I was after Boeing day and night so that the people understand that we're working on it, that we hopefully find the cause and make sure it will never ever happen again, because this is the answers these families needed.
With pressure mounting on Boeing, Bob McIntosh returns to the crash site in search of any evidence that can help explain what went wrong.
Let's get to it.
He thinks there might be another way to get his hands on some of the data that he couldn't get from the badly burned FTR.
We scampered out there with a couple of rudimentary tools like pliers, a screwdriver, and whatnot, and got out there as fast as we could.
The engines of a 767 are equipped with an electronic engine control unit, or EEC. McIntosh hopes the unit's internal memory will preserve a record of how the plane's engines were operating just before the crash.
And sure enough, there was the EEC, the engine electronic control, fully available to us. We were extremely interested in getting that information out of the jungle and into a proper readout facility.
You got a bag there?
The critical question now: can the engine data reveal why the Lauda pilots suddenly lost control of their plane? Investigators may be a step closer to understanding what brought down Lauda Flight 4. They have critical data from the plane's electronic engine control unit.
We now had airspeed and we had altitude information. And although we didn't have exact timings on those pieces of information, it led us to the understanding of the loss of control.
Wow. That'll sure get your full attention.
The data gives McIntosh a clearer picture of why the plane broke up in flight. Operating at nearly full power, the left engine suddenly goes into reverse.
Reverse is deployed! Oh, Christ!
Following the exclamation from the co-pilot, "Ah, thrust reverse," there was a lot of action going on in the cockpit.
Captain Welch immediately tries to correct the problem.
Wait a minute.
The engines had been drawn to idle. And even the fuel on the left engine had been shut down.
Yet just seconds later, the Boeing 767 is plunging to Earth at almost the speed of sound.
No mystery why that plane broke apart.
The sheer force of the blazing descent tears the aircraft to pieces.
If you are in a prolonged dive and that speed increases beyond what the airplane was designed for, the aerodynamic loads can be more than the airplane can take.
The revelation explains the witness reports. The explosion they heard was the plane breaking apart. The fire was caused by the fuel leaking from ruptured tanks and igniting. Niki Lauda travels to Boeing headquarters in Seattle. He's determined to figure out why a failure that's not supposed to be dangerous killed 223 people flying on his airline.
I know what it says, but that's not what happened in Thailand.
And I said to Boeing, listen guys, it's my name, my airplane, my crash. And Boeing understood my problem, or their problem, and we kept on working together.
Lauda's determination echoes the tenacity he showed in Formula One, always pushing his mechanics to gain a slight advantage.
Basically understood that as more you work with your car, your engineers and your mechanics, to make the car on the day adjusted in the right way that it can go quicker. This was the secret.
Okay, let's try it in a simulator.
It was important to push Boeing because they were the only key of the whole matter.
Lauda recreates the flight in the Boeing simulator.
Okay, let's begin.
He wants to know why his pilots couldn't do what the plane was certified to do: recover from a deployed reverser.
Approaching 24,000 feet. Has to be 320 knots. Another 100 feet.
It was incredible, because the airplane just turned around and you couldn't do anything. looking at every sequence slowly and doing it again and again, you realize nothing they could have done.
Lauda's tests at Boeing show that the pilots of Flight 4 didn't have enough time to execute the commands needed to save the plane.
Hard right, auto throttle off, thrust lever to idle, left engine shut down.
There would be a 4 to 6 second window where a flight crew member would have to initiate contrary flight controls to this condition in order to recover in a safe manner.
And before you do any of that, figure out what the hell's happening to your plane. All in 6 seconds? Good luck.
It was just too late. The aircraft was going to assume a very nose-low, high-speed attitude.
Reversers deployed!
It's clear the accidental deployment of a thrust reverser is much more than a harmless malfunction. It can be fatal.
It was evident to the Boeing company and to the FAA certification authorities and to the operators of Boeing 767s around the world that this was going to be a major, major issue.
The finding has staggering implications. Investigators must figure out why the reverser deployed in the first place. According to the aircraft's designers, it just shouldn't happen.
It was pretty obvious after a while to understand that the thrust reverse made the airplane crash. So this was clear, but you still need to know the exact cause, and then especially for the future, what you're going to do to make airplanes safer.
The reverser deployed, and those guys couldn't recover. Let's figure out why that happened.
For the reverser to deploy, it requires you have two separate and independent valves open.
The first valve is the isolation valve that controls the flow of hydraulic fluid. But the reverser won't deploy until a second valve, the directional control valve, moves from stow to deploy. Investigators wonder if that crucial second valve somehow ended up in the wrong position.
To the investigation team, the directional control valve was a very critical portion of the evidence that we needed for analysis.
But the crucial component is nowhere to be found. It's likely that looters at the crash site have got hold of it.
The directional control valve was gold-colored. We speculate that someone thought it had some value just for being scrapped or sold.
We need to find the directional control valve. That's not our top priority. That's our only priority.
They offer a cash reward to get it back.
We really wanted to know what had driven those thrust reversers open, and that was the piece of electronic slash hydraulic equipment that would give us that clue.
9 months after the accident, the reward pays off. Investigators finally get their hands on the piece they need most, the directional control valve.
Someone showed up to claim a reward. They presented the piece of evidence, and it made its way relatively quickly to the engineering assessment lab out in Seattle, Washington.
Investigators are eager to know what position the valve was in at the time of the accident.
In one position, it tells the thrust reverser to stow and remain stowed, and in another position, it tells the thrust reverser to deploy.
Several screws are loose, and some parts are misplaced.
As soon as you see that, you know that you may not have all the evidence you really need.
They find soil inside the component, a clear sign that it's been taken apart and then carelessly reassembled. It's a big blow to the investigation.
It was disappointing that when we received the valve that we knew that it had been tampered with.
Engineers will need to find another way to uncover what went wrong on Lauda Flight 4. Niki Lauda continues his quest to understand why the pilots of Lauda Flight 4 couldn't save their plane. He reviews Boeing test data that shows a 767 should lose only 10% of its lift if a thrust reverser deploys accidentally.
Trust me, if they had lost only 10% of their lift, they would still be here.
Lauda compares the flight conditions used during the Boeing test to the conditions his pilots faced at the time of the accident. He makes a stunning discovery. The Boeing test flights were at a relatively low altitude, just 10,000 feet.
nobody tested it high up. It has a hell of a difference if you fly in 10,000 feet or in 28,000 feet. And this is exactly what that certification misinterpreted.
The Lauda 767 was flying twice as fast and at more than twice the altitude of the Boeing test plane, a height where the thin air makes it much more difficult to maintain lift.
We started to home in on the issue of a possible loss of lift from the affected wing.
Boeing engineers can imagine only one scenario that might make a reverser deploy unexpectedly in midair. The theory calls for the accidental activation of two key valves at the same time.
You have to have both the isolation valve open and the directional control valve at the engine open to the deployed position.
The problem is, they can't figure out how to make that happen. And until they do, it will be impossible to prevent it from happening again.
There's a number of combinations of things that you needed to look at, like a bad relay and a cut O-ring, or a shorted wire, say, and debris in a valve that would combined cause the unwanted deployment.
The engineers can find ways to activate one valve or the other, but it seems impossible to trigger both at the same time.
It's always frustrating when you spend a tremendous amount of time and effort and you want to find out what happened and you just can't find the smoking gun.
A catastrophic accident can destroy small airlines. Niki Lauda is determined not to let that happen. The plane he lost represents a quarter of his fleet. He needs another plane in the air to keep his business.
One of his major assets was his competition spirit, and he wouldn't accept no, and that's not possible.
He finds a jetliner in France that no one is using. Within weeks, it's been added to Lauda's fleet.
I picked up a 767 in Paris, flew it to Vienna to replace our crashed airplane to keep on flying our schedules. To run the airline business is harder than to win 3 world championships in Formula One, I can tell you that, because the business challenges in an airline are enormous.
The tests at Boeing finally pay off, and the engineers make a major breakthrough. They're now able to trigger the double failure needed to accidentally deploy a reverser.
We could get that system to activate by introducing a short, a direct short in a system.
The wires for both valves were bundled in the same harness. A fault across several wires in that harness could have triggered the simultaneous short circuits. But because the wires were so badly burned in the crash, there's no way to determine what caused the short in the bundle.
Scheiße. Yeah, that keeps, let's come on.
The theory accounts for the intermittent warning in the cockpit.
Shall I ask the brand staff? No, it's probably moisture or something.
It also explains the deployment of the thrust reverser.
Two shorts in two valves at exactly the same time? What are the odds?
Reversers deployed! Oh, Christ!
I was upset that the airplane did something where a human being couldn't react anymore.
What we had learned was that the in-flight deployment was something that could happen when we never expected it would.
To the aviation industry, it was a bit of a come-to-Jesus moment.
We couldn't allow airplanes to be out there flying where that could happen.
One of the most shocking lessons learned from the Lauda accident is how serious a reverser deployment can be at high speed and high altitude.
There were other airlines that joined in the questioning of how could this possibly affect the flight path to the point where you lose control.
The answer to that question goes back to the 1970s. To increase fuel efficiency, designers move towards sleeker aerodynamic designs. They begin mounting engines closer to the crucial leading edge of the wing.
In the case of the 767, they're up way closer to the wing, and their relative size to the wing is much bigger. So the effective reverse thrust on the 767 would be way greater than it would be on a 747.
The design of the thrust reversers also changes. Earlier models used buckets at the rear of the engine that redirected air near the back of the wing. Newer designs redirect air closer to the front of the wing. To find out how the changes might affect aerodynamic lift, NASA runs a series of special test flights.
Okay, your rear order's on.
Flying a DC-8, NASA pilots match the Lauda flight's high speed and altitude.
Okay, should be deploying those.
Then they deploy a reverser.
There they go.
The results are dramatic.
There was about a 25% loss of lift over the affected wing. That loss of lift would result in a roll rate that would be extremely difficult for a flight crew to combat.
Deploying one reverser while keeping 3 engines operating normally sends the DC-8 into a terrifying dive, falling at almost 9,000 feet per minute.
Okay.
The experiment reveals why Flight 4 lost so much lift. Unlike previous designs, modern reversers disrupt the smooth flow of air over the wing, which decreases lift. The stunning results change commercial aviation worldwide. In-flight deployment of a thrust reverser is no longer considered controllable. And a series of mechanical locks now ensure that even if both valves get energized in flight, the reversers can't deploy.
There were some major efforts made worldwide to make sure that the improvements of a sync lock system were installed in every operational airplane and every airplane that was manufactured thereafter.
For Niki Lauda, it is total vindication.
I was affected myself. I was affected as a pilot, so this drove me all the way to the extreme to find out as quick as possible what happened.
The sports hero has gone from winning championships to protecting the lives of passengers.
Niki wanted, for his own sake, to have the matter cleared, and of course for the sake of any passenger who stepped into a 767.
Lauda Air continued to operate for 9 more years after the accident. In 2000, it was folded into Austrian Airlines.
For me, the worst thing in life is gray areas. I hate gray areas. And there are a lot of airplane crashes been in the past where you really do not know exactly what happened. And in this crash here, thank God, it was clear what was the cause. And it was fixed for all airplanes worldwide. So I think this is the only good thing out of this terrible crash.